Okay, so this sheet was a little longer than the yesterday's sheet. The quiz next is more like yesterday's sheet. So, haha, you picked the second sheet. But anything that was new on this, it's not going to be on there. Well, so 1, 2, 3. Yesterday there were 2 of these questions. Today there's 3. So I mean, more practice didn't hurt anybody, but the quiz will have 2 of these. So again, like yesterday, you're going to start off by doing the derivative, and then you're going to factor, and that should give you 2 numbers, which would get you 2 as well as -1. I'd agree. Then you do another derivative, potentially another factor sometimes, but not in this case. And in this case, that'll get you 1 more number, which is a fraction, which is a half. And then we go from left to right. -1 is smallest, half is in the middle, 2 is largest. And the pattern's going to go increase, decrease, decrease, increase. And it's going to go down, down, up, up. Then we go get ourselves our y's. -1 gets you a fraction, y coordinate, or a mixed number, or a decimal. 1.5, 3 halves, 1 1/2 is fine. Half's going to get you a negative fraction, or -3/4, either way, yep. And 2 gets you a negative whole number.
-3.
Agreed. And then I think it's the same shape we got yesterday that I'll trace out with my finger while you can look at my finger and make eye contact with my finger. But it's just a little swoop, a little mountain, a little valley, a recovery up. If you're looking for some sense of scale, it should cross the y-axis at a height of 1/3, which you don't have to find at, but it's nice if you do that for me and make your graph a little bit better. If you plugged in 0, you can easily get out 1/3, and that tells you that the y-axis touch point is at 1/3. X-axis, it probably touches around -2-ish, but we're not really sure. We don't really know where it crosses the x-axis to the right either, and that's all just sort of guesstimating. But question about 1 and all?
What were the decrease, increase order?
Increase, decrease, decrease, increase. And if you graph it on your calculator as a check, that's highly recommended. If you do mess up one of the increases or one of the up-downs, you'll get a thing where like you try to connect this to like that. And you're like, that looks bumpy, you know, and that would usually give away maybe that if this shape can't connect the dots in a way that looks practical, you know, we're not going to go like this and then like run into the back of another one of those to go like hump hump, like a bunny hop. Anybody else? 1? 2, it's another x to the 3rd problem, so it works the same way. The first derivative gives you 2 numbers, both whole numbers, which will be
0 and 1?
not from the first derivative. 1 and -1 from the first derivative. Second derivative will get you 1 number, which is a 0. So we're going to go -1 first, 0 in the middle, 1 farthest down, and that's going to go same exact pattern as we just did. Increase, decrease, decrease, increase. It's going to go down, down, up, up. -1's partner is 5, 0's partner is 3, 1's partner is 1, and then it's the exact same shape. The y-axis touch point will be at 3, which we already knew that point. The x-axis touch would just be a guess. I'm not sure where that's touching exactly. Don't feel like figuring it out. So it's that again, mountain, valley, keep rising. Something about 2. 3 is a little different shape because it got as high as x to the 4th. So derivative and factoring still gets you 2 numbers, but it could get you 3 in a different setting because we have an extra power to play with. But when you factored off an x squared as a GCF, what were your 2 numbers from first derivative? 0 and 3. Agreed. Second derivative gives you 0 again, as well as 2. So from left to right, it's 0, 2, and 3. The pattern is different on this one. It's going to go increase, 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 3 increases before a final decrease. And it's going to go down, down, or excuse me, down, up, down, down. So mostly downs, other than that second piece was an up. And then go get partners. 0 gives you out 0, 2 gives you out 16, 3 gives you out 27. And to me, from the perspective that I'm sitting, it looks like a thumbs up. So from your perspective, I'd have to mirror that. So it looks like that to me. It's sort of like an uphill half, then it swoops up, it turns over, and just falls. Fourth power things tend to look like thumbs. Third power tend to look just like Mountain Valley combos. Something about 3, 1, 2, 3. So again, whether tomorrow has an x to the fourth or not, I'm not sure, but what I am sure of, it has 2 problems, not 3, just to save some time. If I were creating a quiz today, I would do 1/3 power and 1/4 power. I don't know what mood I was in when I created the quiz, because I didn't create it this year. Something up to 3. Then we're out of order. The easy page came second, and the harder page is coming later. So easy page on 4, just remember your plus C's. That's an unfortunate way to miss half points. You don't want to do that. But 4, I'm going x squared, then 1/5 x to the 5th, then 3x to the 4 plus 6x, then a negative cosine x, then a 1/5. Make sure for the triggy ones you get those numbers out in front. If there's a number with the x, we need fraction fronts. So 1/5 secant 5x. 9, rewrite with some fractions. Final answer is 2/3 x to the 3/2 plus 2x to the 1/2 plus c. Then 2x to the 1/3. Then 3x minus 2 cotan 2x. Then rewrite with negative powers on 12. Final answer is negative 6x to the negative 1. And then cap it off with 1/8 x to the 8 minus 3x squared plus 8x plus c. Anything there. What's the next page have? I think my pages are out of order maybe. Is it the dy dx question? Is that what's next? Okay. So, this sheet has 4 of these. The test, I'm sure, has 3 of them, just like the paper yesterday had 3 of them. So, 14 is going to be 10x minus half x squared minus 1 is the final answer. 15 is going to be t plus sine t plus 4 is the final answer. Be careful on your trig, because just because I gave you 0 doesn't mean the trig is always going to give you 0. This it did, because cosine turned into sine, which is a 0. But yesterday sine turned into cosine, which is 1, and that changes the value of the c by 1. Something about that pair?
What was 15?
15 is t plus sine t plus 4. Need detail on that at all?
Yeah.
Yep. So antiderivative would be a t plus a sine t plus a c.
Okay.
You with that?
Mm-hmm.
Then if we plug in, the t becomes 0, sine of 0 becomes 0. The c has to be a 4, because that left side, the ds dt thing, turns into just an s. So it would have been s equals that stuff I said. So if the s is going to be 4 and everything else got zeroed out, the c has to be a 4. Anything else? 15 page. 16 page, we'll go through 2 levels. So I'll go first level first. So my first level, I had 2x minus 3x squared plus a 4 that I solved for. And the final answer is an x squared minus an x cubed plus a 4x plus a 1 that I would have had to solve for. But it's an easy solve because I zeroed away everything by giving you a kind problem in its creation. 16 stuff.
What was the final one again?
X squared minus x cubed plus 4x plus 1. Anything else needed there? 17, that 4 in parentheses means it's a fourth derivative, so we're going to have to run through 4 levels. There was a homework problem like this. If you didn't get to that page yet, they did one where sine turns into cosine and cosine turns into sine, and sometimes the positive negative signs switch. But when you go through 4 derivatives, you end up actually completely back to where you started, but you pick up some extra pieces. So I guess I'll take it a level at a time. So first level is a cosine t plus a sine t plus a 6, not a 7, because cosine of 0 is 1, and that put us off by 1. Then going again is positive sine t minus a cosine t plus a 6t, and this c ends up being a 0, so don't add anything on. Go again, you'd get a negative cosine t minus a sine t plus a 3t squared, and another c that zeros, so you don't have to add anything on. And then the final answer is what we started with 2 new pieces, a negative sine t from the original, plus a cosine t from the original, plus the t cubed that we picked up along the way, minus a 1 at the end. The quiz will not have one like that goes through 4 levels. But if you didn't complete that homework yet, I could talk you through that one that goes through 4 levels, because there's at least 1, maybe 2 on the homework page that they did cycle through something that was just like this one. Anything there you need? Asymptote page, vertical is again caused when the bottom is 0. So number 1's vertical is the magic number, -1. 2 has a pair of numbers.
1 and -1.
1 and -1. 3 has a fraction number.
-7/5.
Agreed. 4 has 1 whole number,
4.
which is 4. Anybody need anything vertical? Horizontal is the limit as x approaches 0. So if the top is bigger, there's no answer. That happens on 1. If the bottom's bigger, it's 0. That happens on 2. If they tie, you make a fraction. That happens on 3, to be 3/5. 4, the top is bigger again, so no answer. Slant, if we had a horizontal, we don't have a slant, and we only make a slant if the top is bigger by 1. Number 1 has a slant. I would synthetic divide, but you can long divide, whatever you like. It's x plus 2. 2, no slant. 3, no slant, because we had a horizontal, so don't even think about it. 4, no slant, because the top is bigger, but it's bigger by 2. Something about the asymptotes. Dominant terms, if we already have a horizontal or slant, just repeat it. And then we need a remainder from dividing to be the small. So for 1, I'm going to repeat my x plus 2 for the large, and 3 on top of x plus 1 from the remainder of dividing is the small. 2, I'm going to repeat 0 for the large, and the original problem repeats as the small, because we can't even divide it. The remainder is itself. It can't be divided, being that's that way. 3 is the hardest division because you're long dividing. There's no way to synthetic divide it. Synthetic dividing only works for just x on the bottom. So 5x, goose that up. So you're long dividing and there's fractions involved. 3/5 repeating is the large. And then the small, I did -1 on top, and I distributed my bottom to have 25x plus 35. If you didn't choose to distribute the bottom and had 5 on the bottom, like waiting to hit the parentheses of 5x plus 7, that's fine. 4, we hadn't had to divide it yet, so we just have to cave in and divide. I would synthetic divide. The large would be 3x squared plus 16x plus 71. The small would be 293 on top of x minus 4. Does anybody need anything detailed layered in on that?
What was the dominant terms for 2?
2 was 0. And recopy the problem.
Okay.
More on those? Turning the page, there's always one that you'll graph. Generally speaking on these sheets, the one you have to graph, I'll make it so that the division is easier. So usually I'll do the type of division where you can just separate this into 2 fractions make 1 not be a fraction anymore and have 1 stay as a fraction forever. But that's what happens here. So 5, you get a slant asymptote of x and a dominant large of x, because x is what's left standing when you do the division on the first fraction you'd make. The small is 1 over x squared, because that's the fraction that's left standing. Vertical asymptote is 0. Horizontal doesn't have it. So then we try to set about graphing. So graph-wise, there's like several graphs you just have to memorize. X, which we had yesterday's sheet. Y equals x, just cuts that quadrant in half. That's the large dominant term, so we're shooting for that on the outer ends. 1 over x squared, we didn't have yesterday, but we did talk about yesterday. That's the one that looks like a funnel. 1 over x, this quadrant is just flipped down to the third quadrant because there's negatives possible for that. And we're shooting for that when we're in tight. And then we're just trying to draw lines that don't touch anybody but resemble the stuff in their areas. So we're getting super close to this, super close to that, don't cross anybody. Here I need to go from like shadowing this on the inside, taking a turn through the middle, and like squeezing into that little space that's getting progressively narrower and narrower. And that's another one I would say, graph that on your calculator to just confirm that you've got the right shape. Something about 5. I think that's pretty slick. It's like a graph with no dots. Like if you went in an algebra 2, dump in an algebra 2 class, and I say graph this and make it an extra credit question or something, you'd have to build a table like all day long to figure out what that even looked like. And it's very possible if you didn't guess numbers in this zone, you might think it's like mirrors maybe, and you might not catch the turn unless you did a really pretty thorough table to like catch some of these. You would need probably like 3 dots to catch those, and you need about another 3 dots to catch this. Probably need about 3 or 4 dots to catch this, so that's like 10 dots, and they have to be the right dots. That was a quick hitting graph with no dots. Whoever came up with that idea, that's pretty slick. Something about 5. Then is it the sum of the numbers? Set the page that's at the end. Save the worst for last. So 1, you'd want to write an equation, x plus y equals 30, something like that. So 1 letter equals 30 minus the other. Don't do the derivative of that. That's just there for you to set it up. You do the derivative of something with squares in it, because squares sentence is the one that said small as possible. So I started with x squared plus y squared. Then I made it 1 letter squared plus parentheses squared from a substitution, with the parentheses being 30 minus a letter, but I don't know what letters you picked, so I'm just saying letter instead of x and y now. If you FOIL that all out, if you combine like terms and things, I think you're going to get 2 stuff squared minus 60 stuff plus 900, whatever letter that might be in your life. Do the derivative, so it's 4x minus 60. Derivative gives you 15. The partner of that number is 15, and then you hope that that's the small one. So if you do 15 squared plus 15 squared, that is smaller than, say, 1 squared plus 29 squared, or 10 squared plus 20 squared, or 0 squared plus 30 squared, or whatever that might be. If it were the wrong one, then you'd have to hope that there was a boundary. But since I didn't use the word non-negative, there, I guess, isn't really a boundary, so I don't know that you could even get the max. So that would have to be something that I would have figured out as the author of the quiz, that wouldn't be fair. And that's probably what happened on yesterday's sheet, because yesterday's sheet felt to me like non-negative got squeezed in after the fact.
Yeah.
It looked like I was like, oopsies, and then I had to like sneak that in. Something about 1.
When you get do the derivative of the like 2y squared minus 60 stuff, you get 4y squared minus 60.
4y minus 60. You with that?
Now I have.
Okay.
That'd be 15, right?
Yeah. 2 won't make the test, but it did make the homework. So if you're still chipping away on this homework, maybe you'll care a little more than if you're not chipping away on the homework. It also might be on the test, because as I described, quiz is going to have 3 story problems. The test is going to have different story problems. So this does not make tomorrow, but maybe it is on the test. I don't know. It's definitely in the homework though. So I started off with an equation, something like 2 letter plus 2 other letter equals 12. I solved that to get one of those letters alone, and it would be 1 letter equaling 6 minus the other in some way. The equation I want to do the derivative of is the area equation, which would be 1 letter times parentheses 6 minus the other. Distribute that, do the derivative of that. It should give you a 3. 3's partner is another 3. I want you to figure out the actual area. So 3 times 3 would get you a 9. 9 is the real answer. If you want to be sure that that's the right thing, you could try other numbers with perimeters of 12, like 2 and 4 would give you a perimeter of 12 and an area only of 8, so 9 is the most. Or you could do a second derivative. If you do the second derivative of 6 minus 2 letter, it's -2, which is negative, so concave down, which has a top or a max, and we wanted the max, so we're good. Something about 2. 3, picture is helpful. Before I did my foiling, I had a volume of a 16 minus a 2x, foiling out with a 10 minus a 2x, distributing an x as well. I foiled and went and did the derivative. I didn't feel like trying to factor the derivative because it looked kind of big, so I just ran my quadratic program, and it gave me a 6.66, which is too big. You can't have the 10 subtract a pair of 6's, so that's a throwaway, 6.66, and it gave me a 2. 2 is a keeper. So I want all 3 dimensions. So one of the dimensions is 2. The other dimensions are 12 and 6. How you're getting the other dimensions are 16 minus 2 times 2 and 10 minus 2 times 2, where we had the parentheses from the original line. That would probably, if I were going to guess, is the most comfortable problem for you.
Yeah.
Because we did it first. That was the first one you ever saw. And it happened in the homework, and it's happened on every sheet. Something about 3. 4 probably annoyed you at first. I'm hoping 4 has grown over time, maybe. 4 is a little aggravating if you add the wrong number the wrong place. And 4 is a little aggravating if you don't remember to add the margin doubly so, because there's a margin on each side. So first thing I wrote from the first line was letter times letter equals 60. And I don't know if you're using L's, W's, or X, Y's, or A, B's. It doesn't really matter. But letter times letter equals 60. So one letter equals 60 on top of the other. Then the equation I want to do the derivative of is a set of parentheses of side-to-side letter plus 6, foiling with up and down letter plus 8. If you foil that out, well, first I would do a substitution, and then you foil that out. One of them's going to have a letter on the bottom. The way I did it, I had 360 over a letter, but the way you did it, maybe you had a 480 over a letter. But there should be somebody over a letter depending on which path you took, depending on which way you substituted. The path I took, I got to a letter squared equals 45. But it's also possible if you took a different path than me, you could get a letter squared equals 80. Either way you do that, that's going to be a root that's going to simplify. So if you were on the 360 path, you'll get 3 root 5 first. If you were on the 480 path, you're going to get a 4 root 5 first. But when you go to get the partner, you're just going to get the other one. So there's a 3 root 5 and there's a 4 root 5 are the two numbers for the letters of the printed space that's the inner rectangle. The outer rectangle, then, you have to add on a couple 4s to the right thing and add on a couple 3s to the right thing. So the 3 root 5 adds 6, the 4 root 5 adds 8, and those are your dimensions. So 3 root 5 adding 6 is one of them, 4 root 5 adding 8 is the other one. And I can try to layer in some details, but first you probably need to tell me which road you were on. Or even before that, maybe I need to help you get on a road, I don't know. Something I can do there?
Yeah.
Yeah. What can I do for you?
I got to the foiling part,
Okay.
and I foiled it out, and I need to do a substitution.
Okay. Do you have a fraction? Okay. Do you have like a fraction plus 8, letter plus 6, or do you have fraction plus 6, letter plus 8? Well, first, do you understand why there's a fraction?
Yeah.
Okay. What letters are you using?
X and Y.
Okay. So you have like xy equals 60.
Mm-hmm.
Then which way did you go?
X equals 60 over Y.
Okay. So then you'd want to go 60 over y plus 6. And letter plus 8. I do believe.
Yeah.
Does that make sense?
Mm-hmm.
Okay. So if you foil, did you get around to foiling yet?
Yeah.
Okay. What did you get foiling?
I don't know if it's right though.
Well, you tell me and I'll tell you if I like it.
I had an 8x plus a 6y.
Okay, then you should have, if you have the fraction adding 6, then I'm going to disagree. If you had the fraction adding 8, then I think I would agree. Which road were you on?
Fraction plus 6.
Okay, so if you're going fraction plus 6, letter plus 8, when you foil that, you'd have the 6 multiplying the letter.
So it would be 60y squared.
No, because you have a 60 over y
Mm-hmm.
times the y. Those are going to cancel the y, so you would just get
yeah.
a plain 60. And I didn't even write that down when I did my path because I'm going to do the derivative of numbers and they're going to vanish, so I didn't even write them because I'm lazy like that sometimes. But you'd get a 6 letter that's left standing. Do you see foiling coming up with a 6 times a letter?
Mm-hmm. This 6 times y.
And there would be a 480 on top of a letter.
Mm-hmm.
And then there's going to be another number, but I don't care about it. I didn't even write it down. But you'd have a 6 letter plus a 480 over letter plus some numbers, 2 numbers, so we don't even do that. They won't matter. You with that?
Yeah.
Okay, then rewrite that as 480 letter to the -1. And now do derivatives and stuff and see if you can take it from there for a little bit.
Yeah.
The derivative should get you to a -2. The -2 you're going to want to rewrite as a fraction again. That's going to involve a little bit of cross multiplication at some point in the algebra. And since the letter's to the -2, that's a square, you'll end up having to root it. Does that stuff make sense?
Yeah.
You need anything? Anybody else? We all right? So, quiz tomorrow, because that's all the sheets I own. That's a wrap if you can hit the stop button.